We're going to go ahead and finish up lesson 5.7. In the first part, we just verified or proved the double angle and half angle identities for sine and cosine. Now we're going to use those in a couple different types of questions here. In fact, we're just using, in these first couple, we're just using the half angle identities. So examples, find the sine of pi over 8. Well, pi over 8 is not one that we are familiar with, but what we do know is pi over 8 is actually half of pi over 4. So we did some sum or difference identities earlier to help us with some different angles that we weren't familiar with. So just so you know, pi over 8, that's a 22.5 degree angle, because pi over 4 is 45 degree angle. Pi over 8 is 22.5. So we're really finding half of 45, or in this case, we're doing this in radians. So this is half of pi over 4. So what we do is we rewrite this as pi over 4 over 2. And the reason we're writing it this way is because we are familiar with sine and cosine and tangent of pi over 4. We know those values. And so what we're going to do, this pi over 4, all I have to do is look to this highlighted part right above. So we're looking at this right here. Theta, this theta is pi over 4. And so now I'm going to do the square root, and I'll talk about the plus or minus in a minute, of 1/2 times 1 minus cosine of theta, which theta is pi over 2. Sorry, pi over 4. Well, what sign goes out here? Is it plus or minus? Well, what we do is we look at sine of pi over 8, that is in the first quadrant, and sine is positive in the first quadrant. So we know this is positive. You actually don't have to put the positive, but just to remind myself that I did already think through that. And now we just simplify. So we have the square root. We can distribute, well, we'll have 1/2. 1 minus this cosine of pi over 4 is root 2 over 2. The rest is just simplifying. So we've done radicals before. It's just a matter of simplifying. So we will distribute the 1/2, which is 1/2 minus root 2 over 4. Well, they have two fractions there, so we're going to get a common denominator of 4, so we're going to multiply this one by 2 over 2. So we have the square root of 2 minus root 2 all over 4. However, we can do the square root of the top over the square root of the bottom, the square root of 4. But what's the square root of 4? I'll write it in here for you. But so you do the square root of the top over the square root of the bottom, and then denominator is just 2. So that is the exact value of the sine of pi over 8. It's a little bit weird because we have a square root within a square root, but that works out. Remember, we talked about earlier, we could plug sine of pi over 8 in our calculator, plug in this value into our calculator, and that will help you check the answer to see if it's right. All right, the next one, cosine of pi over 12. Find that using a half angle formula. Now, we've already worked with cosine of pi over 12 or sine of pi over 12 when we did sum and difference identities, but this is just another way, another tool that we can use to get the same answer. So we're going to use a half angle formula. Well, cosine of pi over 12, cosine of pi over 12 is half of what angle? Well, cosine of pi over 12 is half of pi over 6. So we can think of this as cosine of pi over 6 over 2. And that fits right into our half angle identity for cosine. Pi over 12, let's go ahead and decide on our plus or minus right now. That's in the first quadrant, so it's going to be a positive square root. This is 1/2. I forgot a 1 here in my formula, 1. So we have 1 plus cosine. And what does theta represent? Well, theta represents this angle right here. So cosine of pi over 6. And now we can just work through and simplify here. So we have the square root of 1/2 times 1 plus cosine of pi over 6, that is root 3 over 2. Distribute the 1/2. So that's root 3 over 4. We're going to get a common denominator. So we need to multiply by 2 over 2. So we have the square root of 2 plus root 3 all over 4. We can break that up. So that whole fraction's in the square root. Make sure you write it so it looks that way. You can do the square root at the top, 2 plus root 3 over the square root of the bottom, which you probably don't need to write that step, but there it is anyway. So 2 plus root 3 over 2. And once again, you can check that answer by plugging in cosine of pi over 12 in your calculator, making sure it's in radians, and then also plugging in the answer we got here.